Hello and welcome to this Feedinfo webcast, where we will be discussing how to create feed formulations that are nutritionally sound and how advances in raw material testing can help us better see to the needs of production animals. I am Monet Brunt. I am the Perspectives content editor here at Feedinfo, and I will be your moderator for this session. Today's webcast was developed with our partners at BASF and their daughter company trinamiX, and we thank them for their support. Firstly, I would like to explain how this will work if you have not seen a Feedinfo webcast before. We have pre-recorded this session, but our speakers are online right now to take questions in the Q&A chat box, which you will find on the right-hand side of the screen. If you post a question in the questions tab, they will be able to type your response. So please ask away throughout the webcast. We will also be releasing a number of polls throughout the webcast. So if you want to share your opinions and see what others in the industry are thinking, do participate in these in the polls tab. So to begin, I would like to quickly introduce our speakers who will be sharing their expertise on the importance of getting the composition of feed right and how to ensure that formulations, match animals' needs. With us today, we have Heidi van Sliedrecht, who is a nutritionist at Production Nutrition Consulting. We've got Gert Diebold, marketing manager at BASF Animal Nutrition, and Peter Tillmann, NIR spectroscopist at the German Agricultural and Analytical Research Institutes. It is great to have you all here today, and I am looking forward to getting a great overview of the subject from you all. So Heidi, can I start with you and ask you just to introduce yourself and tell us a bit more about what it is that you do?
Okay, so I'm Heidi from Australia. I'm a production nutritionist. I've worked in the industry in the fields of feed milling, pre-mixing, research, animal production for the last 30 years. In the last 15 years, I've focused predominantly on the production side of nutrition, which is making sure that farms in themselves that I'm consulting to get the best animal performance that they can, but also the most profitable performance. So we're very focused on the cost of production as well as the animal performance side. In terms of feed costs, if you just look at intensive industries, for example, the swine industry, the feed cost is 60% of the cost of production, so it's an extremely important area and requires a lot of attention to detail. In doing so, my farms go from central Queensland to Victoria, so it's a 2,000 kilometre spread in which I have 17 different feed mills and 4 different grain areas. So there's a lot of different raw materials, both from Australia, homegrown as well as imported, coming into all those facilities and those farms, which require constant monitoring in order to get the results that the farm wants and the focus on the cost of production. And aside from that, I'm a farmer myself. So my husband and I have a dairy farm, which you can see in the background. So I always have that grounding and that focus on the importance of feeding and on animal production and the cost of animal production and the importance of getting it right.
Fantastic. Gert, can I come to you? Can you tell us a bit more about yourself, please?
Yeah, so I'm an animal nutritionist at BASF Animal Nutrition, and we recently started a partnership with our daughter company in BASF called trinamiX. trinamiX has a very exciting new NIR solution for the animal nutrition industry, and I'm happy to coordinate the activities here between BASF Animal Nutrition and trinamiX.
And finally, Peter, can you tell our audience a bit more about yourself too?
My name is Peter Tillmann. I'm working for the German Association of Agricultural Analytic and Research Institutes, VDLUFA, as we call them in German. My main task is NIR spectroscopy. So I'm living in the world between approximately 800 nanometers and 2,500 nanometers, which is the area of the infrared light, the near infrared light. Everything to the left and to the right of that region, I have no idea about, at least as long as I'm in the office. I'm doing this since 28 years now. I am developing calibrations, providing them to our customers in Germany and Europe and abroad. And I am here to focus a bit the discussion on the scientific part of the subject.
Great. Now, nutrition has always played an important role in helping production animals meet the demands placed on them by the industry, and the nutrient content of feed, like dry matter, moisture, fats, and protein, they all play a crucial role in addressing livestock needs and making sure that these animals can perform at their best. It is therefore essential to know exactly what's inside the raw material, the forage, or the finished feed that we use in order to produce feed mixtures with the right composition that will meet the needs, the nutritional needs of livestock. So with my first question, I would just like to set the scene a bit and ask, what are the biggest challenges that farmers and feed millers and nutritionists are facing in terms of producing feed that is nutritionally sound? Geert, can I get your opinion on that, please?
Yes, sure, Moni. In a way, you already answered your question yourself, because the very important issue is you need to know what's in your ingredients. And table values are simply not good enough, because depending on harvest conditions or different batches, you always have varying compositions in terms of nutrients. And in order to be able to formulate according to the animal's needs, when you know what's in your ingredients, then you're able to. So taking measurements and getting correct results in terms of nutrient composition, that's a key for formulating diets.
Fantastic. So considering this, the varying nutrient compositions of raw materials that can result from a range of factors, Heidi, as our panel nutritionist, how are we currently ensuring we get feed formulas just right?
Well, as Geert alluded to, there's book values can only give you an average value. There's a huge variation in the feed ingredients that come in. Just in what I deal with 17 different feed mills and 4 different major grain areas in Australia. So there's quite a variation. So unless we can test it, we really don't, have much of an idea. And they can be very significantly different between those areas. So at the moment, some feed mills will have an NIR which tests just protein and moisture as it comes in, but we don't have much idea of the rest of the nutritional value of, say, the grains. We have to take composite samples and send them away. And usually I may only get a result at the best once a month for that, or in some cases once every couple of months. So you are sort of working on sort of rolling averages the entire time. So something that's instant makes, you can make decisions much quicker, or even test all of the grains that are going into a silo and be much more comfortable with what your average is going to be.
Thank you for that, Heidi. Now, Peter, Heidi just briefly mentioned or briefly touched on NIR testing, and I wonder if you could, if I could ask you to tell those of us not familiar with this technology a bit more about it.
Well, we have put much work into NIR spectroscopy in the lab just because of very simple reasons. It is cheap, or let's say cheaper than most other techniques. It is fast, and it requires much less sample preparation than we typically have for other analyses methods. And on the other side, with one measurement, we get numerous parameters, constituents of the feed that we are analyzing. And it is reliable in the meaning that the numbers can be used very well for the purpose of ration balancing or for feeding animals in general. So therefore, these are the reasons why we are putting so much work into our analyses on feedstuffs, which is of major importance for forages, because forages are harvested in the vegetative stage, so there is no defined end state like for grains. Grains have to be harvested when they are ripe, while grasses are harvested at any time between 5 centimeters height to up to meters of height. And then the composition varies much, much more than compared to grains or any byproducts from the milling industry or anything else. So forages are the main focus area for applying NR, which is not the sole area, but it is the major area, because we are required to analyze much, much more forages than anything else.
Now, I wonder if I could stay with you for this one too, Peter, and find out more about what are some of the limitations of NIR in feed analysis?
The way we are using NIR is that we are getting samples. If they are forages and contain lots of waters, then we are drying them typically. And then we are grinding them and analyzing them as a dried powder in the laboratory. That is the most used way of analyzing feed samples in the laboratory. The reason for this is that we remove the water, because water is having the strongest absorptions in the NIR. And if the water is in the sample, lots of the other information is not visible as well for the spectrometer. And the other thing is, by grinding, we are able to homogenize the sample so that sample heterogeneity is reduced and makes it much, much easier to get repeatable results. The limitations are water, as I said before. Then some parameters are not measurable in the NIR because they have no absorption bands. Typical things are minerals, because minerals as elements don't have absorptions in the NIR. And then there are features that are in minor concentrations. Anything that's a rule of thumb below 1% cannot be analyzed in these powders. And then there are things like baking quality, brewing quality, where the results are much more vague compared to analyses of protein or fiber or fat.
Thank you, Peter. Now, just based on what we've learned today, this testing of forages and other feed raw materials, this process seems like it's quite long. As Heidi mentioned, in some cases, she's sending away samples and getting results once a month or sometimes longer. Is there a way to make this process more efficient? Gert, can I throw that question to you first?
Yes, of course. I want to take up the example that Peter mentioned. If we talk about forages, let's use silage here. If you imagine that a dairy farmer is creating his feed with silage that he takes out of the silo, he's doing this on a daily basis. If he gets the result of the silage that he's mixing in 3 weeks later, he can then find out that he missed the target of feeding the animal correctly, but he didn't know. And the same problem occurs over and over because there's always this time delay.
Thank you very much, Gert. And Peter, do you have anything you would like to add here too?
Any result that you're producing in the laboratory has to be followed by an action. So if you get a number, you need to react onto that number and do maybe some changes, or you realize everything is in good condition, so that then you can let it go. But if you're analyzing more frequently, then you need to also have the chance to use the numbers and make new decisions. Presently, in most of the situations, we assume that a bunker of silage is one unit, one lot, and there's one number going with it. One number of protein, one number of fibers. And if we look into this assumption, then we do know that any silo has layers, and we know that there is more moisture on the top than in the bottom because it's compressed and the water is pressed out in the lower parts. So we do know that this assumption that the feed bunker is one unit, one lot, is in reality not given. So therefore, we do think that there is a need for more information that is more up to date, quicker available, and that the farmer might be taking a chance to get benefits of the knowledge of this different composition. That's correct. We do think that there is value in numbers that are quicker.
Yes, and I think that it ties in with what Geert was telling us earlier. There is certainly value, as you mentioned, in getting quicker access to composition information to improve feed formulations. Now, Peter, I want to stay with you for this one. So seeing as there is a need for quicker results, what are you seeing in terms of NIR developments that could be of help here?
In my opinion, there are two trends. The one is driven from the application side, from the people that are using the numbers. That is the trend that we don't send samples to the laboratory anymore, but we want to do the analyses where the samples are. That's what is called bringing the lab to the sample. And the other big trend that is going around since 10 years now is miniaturization. Typical laboratory instruments have the size of 50 times 50 times 50 centimeters. Those are bulky instruments. They have to be on a table. They should not be shaken, and no vibration in the room. And we have the trend towards miniaturization, that we have handheld devices since about 10 years now. And those two trends go together well, of course, because small instruments can be carried towards the samples much more easily than the large ones. And we are looking at many developments in this in the industry, whether it's feed or food or anything else, that we bring small instruments to the samples.
Yes, and I think that brings us nicely to my next question, which is, how are we seeing these mobile NIR devices, which we know that BASF and trinamiX have recently launched? How are we seeing putting this technology into more hands, impacting the feed value chain? Geert, can I get your opinion on that, please?
Well, Peter already described the advantages of the NIR, and what the trinamiX solution is basically doing, it's bringing the lab towards the sample. Of course, it's a handheld device which can be applied right in at the location where the sample should be measured. So it's not just a question of where in the industry, but also how often the industry can measure and take analytical values throughout the value chain. So it might be an important tool for a feed miller who can control incoming raw materials quite easily, or for the farmer who's harvesting his own grain when he puts it into a big silo that he knows, like Heidi mentioned, the average. And especially when we talk about forages, which is the most varying factor in feed, it's very important to have continuous possibilities to measure.
Now, Heidi, as a dairy farmer, I just wanted to hear from you too on this. Are there any impacts that you're seeing or expecting?
Yeah, I'd agree with that. The more instant you can get results, the more quickly you can make a decision, particularly when you're talking about dairy cattle, because you see a result in the milk the next day. So sometimes you know something's wrong, but you don't know, what to correct. Whereas in this case, you could measure it and be able to fix it the next day. So yeah, with silages, when you're loading the pits too, you can be taking off different paddocks. It may change as you go, through the silage pit or as you're taking it back out. And then in this case, you're also going to be able to take measurements as you put it in. So you're going to have more idea of what you're actually going to be feeding in the future. But it certainly is a value. And just on that, like we buy a lot of hay from a lot of different areas of Australia, but it's going to be exceptionally good value to be able to test every load that comes in and the one that we're using at the time to make sure that we are balancing it correctly in the mixer wagons.
Perfect. Thank you all for that. Now, just before we wrap up our discussion, I was wondering if any of you have any final thoughts that you would like to share with our audience. Heidi, I'll stay with you. Any thoughts to share?
Well, I think part of the value of this instant technology is not just measuring the incoming raw materials, but it's the fact that it also measures the finished feed. So you can then check that what you think you've got is actually right. And earlier this week, I was actually on one of my farms that I visit. It is a 4,000 sow farm from farrow to finish, and they have their own computerised feed mill. They traditionally would measure the protein of the grain coming in, but we were also able to measure a lot of different grain samples that were coming in for the next harvest, because the farmers bring the samples in first so that they can approve that they do want that grain. But also we were able to measure some finished feeds and find that they were on target. So in this case, it was exceptionally important. I mean, they are a very high-producing farm. They're in the top 10% of Australia, but they always want to make it better and make their production better and to get that extra saving all the time so that they are more profitable. So they were really excited about this technology. They wanted my machine. I said, no, you can't have it. But they thought it was really valuable, and we're really excited that we could instantly measure the finished feed as well and check, the whole process.
And Gert, any final thoughts for our audience?
I think that was an excellent example. And we also know that during feed processing, when you make your feed, there's also changes on the protein. So that checking the final product makes also a lot of sense, because just adding up the numbers of incoming raw materials is not good enough in all cases.
And finally, Peter, any thoughts you would like to leave our audience with before we leave?
Keep in mind that any information that you can collect with the sensors during production needs to have, on the other side, the chance to use those numbers and make new decisions. For example, when you analyze protein on the combine, which is sold by many manufacturers presently, the knowledge of the protein is one information, but the combine will not stop anymore. When it started to harvest the field, it will not stop anymore, because it is scheduled, because the next day it's on another field. It is scheduled the whole week through. So the knowledge of protein on the combine in the first moment has no effect on what is happening. The only effect is if you have it in your on the farm, you can put it into bunker number 1 or in bunker number 2 or number 3. But the combine itself, the number is useless, because it will continue to harvest the whole day through because of other limitations. So knowledge about protein composition might not be usable in the daily work. The situation must be that way that you can use the number to make new decisions. Otherwise, analyses are meaningless when you can't make a new decision.
Thank you all so much for that. Now, from our discussions today, it is clear that a regular and rapid testing of feed raw materials, especially forages, be it in the feed mill or on the farm, can help improve formulations and make them more effective in meeting the needs of livestock. And making that technology more readily available, can lead to worthwhile impacts on the feed value chain. So thank you to our panel for sharing their thoughts with us. Just a reminder, our speakers are still online and will continue to be for the next 10 minutes or so. So keep putting your questions to them if you have any questions. But I would like to take this opportunity to thank them again. You all brought such a great knowledge and insight to this session today. I would also like to thank everyone who tuned in and contributed to the session today. We hope that you found it interesting and that you tune into future sessions from Feedinfo.